All right, let's talk about one of the biggest headaches in production AI right now. How do you get your enterprise RAG system to go from just finding things that sound similar to delivering answers that are actually truly relevant? Because that, right there, is the difference between a cool demo and a tool your business can actually bet on. So picture this. You've done all the hard work, right? You've chunked your docs, you picked a fancy new embedding model, you've got your vector database humming along. You run your first real query and, huh, the results are kind of on topic, but they don't actually answer your question at all. If that feels painfully familiar, you are definitely not alone. It's probably the single biggest wall people hit when trying to move a RAG project from a prototype into production. And this example just hits the nail on the head. You ask for a customer churn analysis from Q4 2024, and a basic RAG system just sees the keywords customer churn and spits back some general theoretical research paper. I mean, it's semantically similar, but it's totally useless for what you actually need. What you really wanted was that internal report, the one with the actual strategies for Q4. That gap right there, that's the whole ballgame. Similarity versus relevance. This leads us right into something we call the similarity trap. It's the sneaky and wrong assumption that just because a document's vector is mathematically closest to your query's vector, it must be the best answer. And in a complex enterprise environment, that assumption just falls apart over and over again. So let's just get crystal clear on these two ideas, because it's crucial. Semantic similarity. That's what your basic retrieval model does. It's kind of like a blunt instrument, good for finding things in the same ballpark. But true relevance? That's all about intent. Does this specific document solve my specific problem right here, right now? And that, my friends, is a much, much harder question for a machine to answer. So what's the root cause of this similarity trap? Well, we're basically asking one poor, overworked model, our embedding model, to do two completely different jobs. First, there's retrieval, which is like casting a huge net to catch everything that might be related. And then there's ranking, which is like being a master chef, carefully picking out the one perfect fish from the catch. You can't expect one tool to do both of those things perfectly. The solution, then, isn't to find some mythical, better model that can do it all. No, the answer is to hire two different specialists for two very different jobs. One for retrieval and one for ranking. And here's our dream team. On the left, we've got the Bi-Encoder. Think of this as our efficiency expert. Its job is to blaze through millions of documents at lightning speed and just give us a broad list of potential candidates. It's all about recall, making sure the right answer is somewhere in that initial pile. But then, on the right, we bring in the Cross-Encoder. This is our accuracy judge. It takes that shorter list and meticulously, carefully judges each one to find the single best match. It's optimized for precision, pinpointing the most accurate result from that group of candidates. So how does our efficiency expert move so fast? Well, a Bi-Encoder is clever. It encodes the query and all the documents independently, on their own. And because you can pre-calculate and store all your document vectors ahead of time, the actual comparison when a query comes in is insanely fast. That's what lets it scale to millions or even billions of documents without breaking a sweat. Now, the accuracy judge, it works in a completely different way, and this is what's so cool. A cross-encoder doesn't make separate vectors. Instead, it literally takes the query in a document, smushes them together, and processes them at the same time as one single unit. This lets the model's attention mechanism see every little interaction between the words in the query and the words in the document. The result? A much, much more nuanced and accurate relevance score. Okay, so by combining these two specialists, we can now evolve our RAG pipeline from that naive, simple system into a much more precise two-stage solution. And here's what that change looks like. A naive or simple RAG system just retrieves some results and shoves them straight to the language model. The advanced pipeline, though, adds that absolutely critical middle step, re-ranking. We use our fast Bi-Encoder to get a big list of candidates, and then we use our accurate cross-encoder to resort that list before we even think about generating an answer. So is this extra step really worth it? Oh yeah, the payoff is huge. Across all kinds of studies and real-world deployments, adding a re-ranker consistently boosts retrieval accuracy by 20, 30, even 40%. Look at this benchmark. Accuracy jumps from a mediocre 62% to a really solid 87%, just from putting the initial results in the right order. That's a massive win. But of course, you're thinking, what's the catch, right? There's no free lunch, and the cost is a little bit of latency. But here's the thing. The trade-off is almost always worth it. Re-ranking your top 100 results might add around 120 milliseconds to your total query time. We're talking about a fraction of a second. And this is why it's becoming the industry standard. For anything mission critical, in finance, legal, customer support, preventing one single bad answer, one costly mistake, is easily worth a tiny delay. As the quote says, it's just plain economically rational. Okay, so you're sold on the idea. How do you actually build this thing? Well, it all starts with picking the right models for each of the two jobs. For stage 1, your retriever, you need a Bi-Encoder that's fast and has high recall. You've got amazing open source options like the E5 and BGE families, and super powerful, easy-to-use APIs from places like OpenAI and Cohere. These are your workhorses, the models that do the initial heavy lifting. Then for stage 2, your re-ranker, you also have fantastic choices. If you want maximum accuracy right out of the box, an API like Cohere's is a beast, especially for long, complicated documents. But if you want to run things on your own servers, open source is the way to go. A model like MS Marco Mini LM is a great budget-friendly all-rounder, while something like BGE Ranker can give you absolutely top-tier accuracy with that self-hosting flexibility. So let's put it all together. Here's the workflow. Step 1, your Bi-Encoder casts that wide net, fetching maybe the top 50 or 100 candidates. That's your high recall step. Step 2, you pass just that short list, not the whole database, to your Cross-Encoder, which carefully scores and reorders them. Step 3, you select only the new top 5 or 10 results, and that's your high-precision context. You feed that and only that to your LLM. You've basically built a funnel for relevance. When you really get down to it, getting enterprise RAG right isn't just about a new tool or model. It's a fundamental shift in how you think about the problem. It's about moving from a simple search for similarity to deliberately architecting a system for relevance. So if you remember just one thing from all this, let it be this. Building a production-grade RAG system isn't about finding similar stuff. It's about consciously designing and engineering a pipeline that, from the ground up, is built to deliver true relevance. And why does this all matter so much? Because relevance isn't just a technical nicety. It has a direct, measurable impact on the business. When your users get the right answer the first time, their trust in the system just skyrockets. When the LLM gets clean, relevant context, it hallucinates way less. And when your teams have information they can count on, they make better decisions and waste less time fixing mistakes. It's not just a tech upgrade, it's a business imperative. Getting this two-stage retrieval pipeline right, that's really the gold standard for enterprise RAG today. But you know this field, it never stands still. Now that we have a reliable way to find what's relevant, the next big frontier is building agents that can autonomously reason over that information to solve even more complex, multi-step problems. But that's probably a story for another time. Thanks for tuning in.